All right, today I'm going to show you what the unit circle is. So first we need to know a couple things. So first we need to know these three things: sine, cosine, and tangent of an angle. All right, so sine of an angle is equal to the opposite over the hypotenuse, right? So when we have a triangle like this with the angle here, it's equal to the opposite over the hypotenuse. Cosine is equal to the adjacent over the hypotenuse. So the adjacent side here over the hypotenuse. And then tangent is the opposite over the adjacent side. So these two. All right? So now let's apply that to the unit circle. So the unit circle, so first let's imagine a coordinate plane like this, right? And then we're going to want to draw a circle with radius 1. So that means that we're going 1 unit this way, so that means this point is 1, 0. This point is 0, -1, and then I'll fill in these two as well. All right, so we have those two coordinates, and then let's imagine we had a triangle in this circle. So let's take that we call this a terminal arm here, and this would be r here, the radius of the circle. In the unit circle, it's equal to 1, so r is equal to 1. Now let's form the triangle there. So now we have a right angle here. So we can use those same ratios. So let's say that is the angle there. So we know that sine of that angle is going to be equal to, well, we had opposite over adjacent before, but now let's translate that into y and x, right? So this is the x-axis and the y-axis. So sine would now be, instead of opposite over adjacent, opposite over hypotenuse, it's y over r. And then on the unit circle, it's actually equal to just y, because radius is 1. So cosine of an angle is equal to x over r, instead of adjacent over hypotenuse, or just x when we have a radius of 1. And then for tangent, we can think of it two ways. So first we could say that it's opposite over adjacent, so that would be y over x. But tangent is also sine over cosine. So we see sine is y, cosine is x, so it's also y over x. So those are the three main ones. But we have three more trigonometric functions. We have cosecant, secant, and cotangent. And these each have an opposite up here. So cosecant is the opposite of sine. So that means that instead of y over r, it's r over y. For secant, same thing. Instead of x over r over x. Instead of tangent is y over x, this is x over y. All right? So those are the main ratios for each of the 6 trigonometric functions. Now, each location like this is going to have a coordinate, right? So it's going to have an x-coordinate and a y-coordinate. So let's say our angle was 60 degrees, or pi over 3 radians. So now this point here, we know is, or I guess I know, is root 3, or 1/2, comma, root 3 over 2. All right? So this x-coordinate is 1/2, and the y-coordinate is root 3 over 2. And this is actually the square root of 1/4, and then the square root of 3/4. So each coordinate, each angle around the unit circle has a unique coordinate, and I will show you those here. All right, now we know we have 2 pi radians in a circle, so this is going to be 0 degrees. We're going to set it to this line here at 1, 0. And then it also is 2 pi radians. So now I'm going to fill in all of the angle measures going around. All right, now that we have our angles filled in, we can start to see what the unit circle is. So let's say we have the angle pi over 4. We draw a radius 1. It hits the point root 2 over 2, comma, root 2 over 2. So using this information, we can actually find the values of trig functions without a calculator. So let's say we wanted sine of pi over 4. What will we do there? So we know sine is y over r, but when we're on the unit circle, r doesn't matter because it's 1. So y is the value we're looking for. So let's locate pi over 4 right here, and we're going to find that y value. And the y value here is root 2 over 2. So sine pi over 4 is just equal to root 2 over 2. And in every triangle, it'll be root 2 over 2, because let's say I had radius 2. That means in order for the triangle to have that same pi over 4 angle, it would have to be, the side length will have to be root 2 instead of root 2 over 2. Twice the amount, same as the radius, so it has to be proportional. So let's say now we want to define cosine of 2 pi over 3. How do we do that? So again, we have to know our cosine ratio, which is x over r, or same as x. So we're going to look for the x-coordinate at 2 pi over 3. So 2 pi over 3 hits right here at the coordinate negative 1/2, comma root 3 over 2. And so we know our x-coordinate is negative 1/2. So the answer, negative 1/2. All right? And then finally, let's try a tangent. So for tangent, let's try 5 pi over 6. So for tangent, it's a little bit more difficult. We've got to, first we know y over x. Tangent is equal to y over x. So let's find our point here. So 5 pi over 6 gets us to here. So the y value is 1/2 over the x value, negative root 3 over 2. All right. Now when we have two things over the same denominator, we can remove that denominator by multiplying by 2 here and 2 here. So we get 1 over negative root 3. Let's rationalize. All right, and that is our answer. It is negative root 3 over 3. All right, now let's see what would happen if we use one of the other 3 trig functions. So let's try secant of 11 pi over 6. What would we do there? So for this, we're going to have to find cosine first, and then we're going to take the reciprocal, because secant is the reciprocal of cosine. So it's equal to 1 over x. So our x value at 11 pi over 6 is root 3 over 2. So we need to take the reciprocal of root 3 over 2, which is 2 over root 3. All right, now let's rationalize. All right, so that is our answer. It's just 2 root 3 over 3. All right, now I will show you one more thing. I call it the cast rule. So pretend this is the unit circle, right, with our 4 quadrants. We're going to draw C-A-S-T for cast. And this basically says what trig functions are positive in each quadrant. So in the 4th quadrant here with the C stands for cosine. So that means cosine is the only trig function that's positive. Cosine along with secant. Because secant is just the reciprocal. It doesn't change the sign at all. So right, we look here. Cosine's our x value. We have 1/2, root 2 over 2, and root 3 over 2. All positive. And then for A is all. All the trig functions are all positive because everything's positive in the 1st quadrant. And then this quadrant we have sine. Sine's our y value. We're looking over here. All of our y values are positive. And the last one is tangent, the 3rd quadrant, because everything's negative. And when we're using a tangent, it's y over x. So that means if we have a negative y and a negative x, they're going to cancel each other out, leaving us with a positive tangent. And remember, all of these, sine, this should be sine and cosecant. All of these is all, and then this is cotangent as well, and this is secant as well. All right, now let's say we had an angle that's higher than 2 pi, because we don't see any of those values on the unit circle. Let's say we had to find the sine of 4 pi. All right, so now we wouldn't really know what to do here, but we do know that the sine is a periodic function. So it keeps going around and around and around. So it doesn't matter, we can add or subtract 2 pi to this value and it won't change. So let's just subtract 2 pi. So now we get sine of 2 pi. And we can do that. We can write that out here. We can find sine of 2 pi as 0. All right? And we can do that for any angle. If we had sine of 1,000 pi over 6, we could find that too. I mean, we just have to subtract a lot of 2 pi's, but we would be able to find that. Because the graph of the sine function, right? The output, it kind of looks like this. So the angle here, right? This is the full cycle. So it's positive until here, and then negative until here. So it's the same cycle. Or in one cycle here, one period, it goes through all the values. All right? So that's the basics of the unit circle and trig functions. Thank you for watching.